Okay, on this video, I'm going to show you how I made this table here, which is sort of the master table on Class B subnetting a Class B network. Okay, so you can think of this Class B as having, and so what we're talking is fixed length subnet mask. So we're dividing a Class B up into equal chunks, equal sized chunks with our subnetting. And with a Class B, we've got n equals 16. Okay, so we have the first two octets fixed. And we've got two octets to play with here. And it gets a little bit more complicated than when we had a Class C with only one octet at the end to play around with. In any case, with n equals 16, we might have something like a 172.16.0.0/16 network, for example. Okay, basically we've got 16 bits to divide up amongst H and S. So n is equal to 16. N plus H plus S is 32. And so the sum of H and S is 16, and we can give all 16 to the host IPs, none of them to the subnets, meaning we have one big subnet with 65,536 IP addresses and 65,534 hosts per subnet. Okay. Now, as we add more and more bits to the subnet, we have fewer and fewer bits for the hosts, and the number of subnets is equal to 2 to the S, and the number of hosts per subnet is equal to 2 to the H minus 2. Okay, and you can see that we trade off the number of subnets with the number of hosts here. And if I multiply the number of subnets times the number of hosts per subnet, I get the number of hosts total that we have access to. And out of the 65,536 IP addresses here, when we only have one big subnet, we get 65,534 of them. We waste two of them. One is wasted on the subnet ID and one is on the broadcast. But as I crank it down to a /30, I'm wasting half of them, because on a /30 I've only got 4 IP addresses per subnet and 2 of them are wasted. So 2 out of 4 are wasted, and so I've cut my total number of hosts down by half, down to 32,000. Okay, and in every case I have what I call a /P, where P is equal to 32 minus H. Okay, so when H is 16, I go /16. When H is 2, I go /30. Okay, so basically 32 minus P gives us the number of hosts bits. Okay, so I hope that helps on this problem. This table can be used to help you solve lots of other problems. Maybe I'll go ahead and look at this problem down here, number 7, and it gives you a typical sort of scenario where you're asked to see whether or not a particular subnetting scenario is possible with fixed length subnet masks. And so we've got this Class B network. We're going to use fixed length subnet masks, break it up into fixed length subnets, and see, can we fit 20 subnets with 400 hosts each? What we're going to do is we're going to run up this table and go up as high as we need to get 20 subnets. So with the /21 we have 32 subnets, and we get 2,000 hosts each. Plenty for the 400 we need. So 20 and 400 is a yes, and we're going to use a /21, which gives us 32 subnets. Okay, and here I'm going to give you the slash number of the, sort of the smallest slash number. Okay, so A is a yes. 40 with 500. For 40 I got to run up to a /22, but then I've got 1,022 Plenty for the 500. Yes, /22 works there. 60 for 600. It's still a /22. 600 still fits, and that's another yes. How about 80 with 800? For 80 subnets, I got to run all the way up to a /23, and then I've only got 510 hosts per subnet. I do not have 800, and so that's a no. Okay. Now I've got a sequence of 3 of them. No, now I'm looking for 160 with 500. 160 for 500. I have to, for 160, I can't use a /23. I've got to go up to a /24, and I'll get 256 subnets with 254 IP addresses each. 254 is less than the 500 I'm requesting, so E is a no also. Let's see, F, G, and H are a sequence of 3. We're looking for 320 subnets, and we want to know if 300, 200, or 100 hosts fit. For the 320 subnets, I've got to go all the way up to a /25 to get myself 512 subnets, because 256 is not enough for the 320. But when I'm up at a /25, I've only got 126 hosts. And so the 300 and the 200 don't fit, but the 100 does. So F and G are both no, but H is a yes with that /25. Okay, and finally, the last one, 1,000 subnets with 100 hosts each. To get 1,000 subnets, I got to go up to a /26, but I've only got 62 hosts each, so the 1,000 with 100 is a no. Okay. I hope that helps on these problems. You can see how useful this table is when you're trying to solve this type of problem, which is very typical, something that you'll see on a CCNA exam, for example. Hope that helps.